So we're going to look at the intermediate value theorem. Intermediate value theorem is a fairly straightforward theorem in that what it's saying is that if we have a continuous function, this is important, the condition that it is continuous. Okay, so that's very important. If it is continuous, then we know that if we have a point here at A and f of A, and a point here at B, f of B, we know that some point exists at W that is somewhere in between f of B and f of A. So it's got to be somewhere between the high point of this interval and the low point of interval. There must be some points in between. And not only that, we know that this point W exists in between A and B. Okay? So we know that C must be in the interval between A and B. So f of C is inside here. We also know that the lower, it must be above the lower bound and below the upper bound. Okay, so we can't read too much into this theorem in that, first of all, if it's not continuous, I can easily draw a graph that doesn't satisfy this condition. Okay, there's a discontinuity. Well, I know that there are some points W which do not exist in the interval between A and B. Okay, so that's one thing. So it has to be continuous. So that's a very important concept. We're not saying that there is a point up here, although there could be, right? We don't know. This point could be up here. It may exist. It may not exist. We don't know. There's a very conciseness. There's a conciseness about this theorem that we're only going to use this theorem for what we know to be absolutely true. There's no exceptions. Okay, here could be exceptions, right? Because we don't know. It might go like that and never go up above or below that point. Okay, sometimes it might go like this. It might go well below and well above, and we can find points, below and above the interval. But the intermediate value theorem cannot make any claims about anything on the outside here. It can only make claims in this region here. Anything below this line, anything above this line. Okay? Furthermore, when it comes to what's happening in the x-axis, we also have some constraints. We know that the C value has to be constrained between here and here. Okay? So we know that when we find C, it's going to be in here. So what we can't say, though, is that every point C is going to be found in the interval squeezed between above A and below B, because again, we can see clearly that there's at least one exception, right? So the reverse is not true. We can't say that there exists some C value where we're always going to find values between f of A and f of B. So the reverse is not true. Okay, so what the intermediate value theorem is stating is only this. If we have a low point, if we have a high point, some point in the middle must exist as long as it's continuous, and it must exist in this interval. And that's it. We don't want to have, it's not saying any more or any less. So a simple application of this would be this. Okay, we sometimes find zeros using this process, or confirm that there must be a zero. So if f is a continuous function, and again, that's a very important condition, because if it breaks that condition, we cannot apply this intermediate value theorem. We know that, so I'm just going to sketch this out, f of negative 2 is here at 5, f of 8, okay, way out here, 8 is at negative 17, way down here. Okay, and we know it's continuous. We don't know if it goes up and down like this. We have no idea. But what we do know is that between the upper and lower, the point here must exist, and it must be in the bound that we've described. Okay, so I have my upper region, I have my lower region. The zero, this is what I'm trying to claim, is I'm going to try to claim something about this zero. Okay, about that point right there. It's between the upper and lower, So that fits that criteria. If that's true, then it must exist. And not only that, now I can make the claim that if it does exist, it has to be in between these bounds. Okay, so it has to be in between -2 and +8. So what do we know the x value when f of x equals 0? No, we don't, but we can at least say that this x value exists between 8 and 2. Okay, and that's true. Okay, so here is another one. We say that the following table, this is a wheel spinning, okay, rotating different values at different times. So at 0 seconds, it's rotating this fast. At 3 seconds, it's rotating this fast, etc. It says that the rotations per second is continuous, so it doesn't go from 72 right away to 95. Okay, there's some kind of, it has to hit all the values in between since it's continuous. Is there a t value in the interval between 3 and 5 where r of t equals 106? Okay, well this must be true because in this interval, okay, we know that we have a low point of 95 and a high point of 112. Okay, so if I sketch this in, that's between 3 and 5. Okay, should maybe make my scale a little bit more accurate. I have 95 rotations per second. I have 112 rotations per second up here. Okay, and I don't know what's going on. We just know it's continuous. It could be like this. It could go down and come back up. We don't know. Okay, it could just go straight across. We don't know. But regardless, any way we draw this, we know that 106 must occur somewhere in that interval. Okay, and in this case, 106 is very close to that point there, to the endpoint, but we know that it is in between those two endpoints. Okay, so C must exist. Okay, so that T equals C must exist, and it must exist in this interval. It's got to be after 3 seconds, after 5 seconds. Now, could it happen twice? Yeah, absolutely. We've never said that it can't happen twice, but we say that it happens at least once because it could look like this. Okay, and it could happen multiple times. We don't know, but we know it happens at least once. Okay, and that's all the theorem can state, that it must exist at least once in that interval. Okay, so that's the intermediate value theorem. Okay, and again, the key part of that is we have to have a continuous function, and it's just making claims, with our lower and upper within that x-axis bounds. Okay, all right.